Greetings. My name is Elizabeth Wade. I teach basic calculus for the mathematics department at Pellissippi State Technical Community College. This is topic 3 on applications of the derivative and segment 3.1 on marginal analysis. The total cost in dollars incurred each week by a company for producing X units is given by this cost function, 8,000 plus 200X minus 0.2X squared, as long as production is kept between 0 and 500 units inclusive. What is the actual cost for producing the 251st unit? What I would do to work this problem algebraically is find out what the total cost is for producing 251 units. First, I would do this by substituting 251 into the cost function. This yields a total cost of $45,599.80 for producing 251 units. Then I would calculate the total cost in a similar manner for producing 250 units. This yields $45,500 units. When you subtract these two figures, you get $99.80. So this would be the actual cost for producing the 251st unit. Suppose that I change this problem to this statement. Find the rate of change of the cost function at a production level of 250 units. To do this, I use the derivative of the cost function, evaluated at 250. So the derivative of the cost function, C prime of x, would be, well, the derivative of 8,000 is 0, 200x, that would be 200, and minus 0.2x squared would yield minus 0.4x. This is the derivative, and now I substitute 250 into the derivative. So that would be 200 minus 0.4 multiplied by 250, and this yields 100. Notice that this answer closely approximates the actual cost for producing the 251st unit, which we obtained $99.80. Based on this type of reasoning, economists have developed these definitions. The derivative of a cost function is called the marginal cost, and it is the cost of increasing production by 1 unit at a production level of X. The derivative of a revenue function is called the marginal revenue, the revenue resulting from the sale of 1 additional unit at a production level of X. And finally, the derivative of a profit function is called the marginal profit, and that's the profit resulting from the sale of 1 additional unit at a production level of X. Let's look at another problem. The price-demand function for a certain product is given by P of x is equal to 100 minus 0.01x, where P gives the price at which people buy X units. First, let's find the revenue function. Well, the revenue function is equal to x times the price-demand function. So I'm going to take x and multiply it by 100 minus 0.01x. This would give 100x minus 0.01x squared for the revenue function. What is the revenue when 100 units are produced and sold? Well, I would plug 100 into the revenue function. So that would give me 100 multiplied by 100 minus 0.01 times 100 squared. This yields a revenue of $9,900. Now let's find the marginal revenue function. According to the definitions that we just established, the marginal revenue, MR of X, is the derivative of the revenue function. So the derivative of the revenue function, well, the derivative of 100x is 100, and the derivative of minus 0.01x squared would be minus 0.02x. So this is the marginal revenue function. What is the marginal revenue when 100 units are produced and sold? I'm going to plug 100 into the marginal revenue function, and so this would give me 100 minus, I'm looking here, 100 minus 0.02 multiplied by 100. And if you subtract 100 minus 0.02 times 100, you get $98. So if we interpret this, what this means is that at a production level of 100, the actual revenue is $9,900, but that revenue is increasing at a rate of $98. So the revenue generated in increasing production from 100 to 101 units would be $98. Well, that is it for this segment. Now you need to practice this concept by working similar problems. Good luck.